Alright, the last problem, 62, is playing around with the fact that another form of orbital kinetic energy, gmm over 2d, is very similar in structure to the force of gravity. So we're going to use that to sort of manipulate things to our advantage. So in 62, we have a satellite orbiting a planet, so a little satellite orbiting around at a certain radius. It's interesting. Certain radius r, where r is, we're going to call this r1 because we need a new radius later on. That's 2e to the 7 meters. The force of gravity exerted at that location is 80 newtons. So in part A, we need to find the kinetic energy of the satellite at that point in the orbit. First off, notice that Fg is g m over r squared, right? And so, and notice that Ke is g m over r, 2r. So what would we have to do to the force in order to make it look like kinetic energy? Well, one thing we could do is multiply by r and divide by 2. Right? Because if we multiply by r, then the force by r, then this r, one of these r's down here cancels with this r, and so we're left with 1 r on the bottom, which makes it look like kinetic energy. And then if we divide by 2, then this 2 appears as well. So if we add this factor, then it looks just like kinetic energy. So we can use that to our advantage. And we know that the force is 80, so all of this equals 80 times r over 2. And that will get us the kinetic energy. So Ke is 80 over 2r. I brought the 2 over here, which is just 40r, which is, we know that r is 2e to the 7. So this becomes 8 times 10 to the 8 joules for the kinetic energy. See what I did there? I just basically manipulated the form of force so that it looked like kinetic energy. So for part B, when we need to find the force, if the radius were increased, we're going to do the same thing but kind of in reverse. This is part A here. Part B. Alright, so the first thing is that, again, the form of force is g m over r squared. We have a new radius, though. We want to know what the force is at a different radius, where r2 is 3 e to the 7 meters. So we're going to call this r2, the force of gravity at this new location. Now, what can we do so that because we now know the original kinetic energy, and so we could slightly manipulate this so that there is a kinetic energy in here. What we could do is g m m. So we need to make because the kinetic energy, which is 8 times 10 to the 8 joules, looks like this, where this is actually R1. Might as well just do this now, just to make it look consistent. Right? So we want to have this in here. So let's just do it. Just write it out. R1, right? Okay, but we still need to make this equal to this. Well, we need an R2 squared on the bottom, because that is in the bottom of the force. This is taken care of right here, but this is non-existent over here. So the way to take care of that is to make something that will cancel it out. So as you can see, I'm going to do it in a different color so that, because I'm not really canceling out, but this would cancel this out, and we're left with just the original GMM, see here, over R2 squared, right? But we want to keep this stuff, because this right here is equal to that, which is equal to that. So this really just equals 8 e to the 8 times 2r1, this, over r2 squared. This will give us the new force at this radius, just by manipulating a little bit to get it to look like kinetic energy. So that's a pretty powerful algebraic technique. I don't even know what it's called, but it's kind of cool. Anyway, so 8 e to the 8 times 2 times r1 is 2 e to the 7, that's this right here, over 3 e to the 7 squared, and that gets you a force of 35.6 newtons. So that should make sense, because the farther away you get, the weaker the gravitational force, and our new distance is farther away, and so the new force, 35.6, should be weaker than the original force of 80. So that works out. Alright, so that was just, again, playing around with this new form of kinetic energy. We're used to it being 1/2 mv squared, but in terms of orbital mechanics, we can write it as this form. So, okay, so that's it for the sample problems. Hopefully this helps you out for the web assigned problems and the quiz and test. And yeah, let me know if you have any questions.